Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the properties of determinants. Last time, we learned how to use the minors and cofactors of a matrix to work out its determinant. Today, we will get more practice on this tricky subject and find out the universal properties shared by all determinants. Are you ready? Let us begin today's lesson. First, let us be reminded as to what a determinant is. The determinant of a square matrix is a real number associated with that matrix. It is a scale factor, also called a coefficient, for measure when the matrix is expressing a linear transformation. For instance, a 2 by 2 matrix with a determinant of 2, when applied to a finite area, will transform those points into a set with twice the area. You see, students, that determinants can be very useful in solving simultaneous equations. We will calculate the determinant of this matrix together. Do you notice anything significant about it? That is correct, students. It does have a column of zeros in the middle. I wonder what effect that will have on our calculations. When we expand using the second column, the results look like this. Our determinant is 0. That must mean that if a matrix has a column or row of zeros, its determinant must also be 0. We have discovered one of the universal properties of determinants. Well done, students. Now, let us try our hand at this matrix. There are no zeros this time, but you can see that the first and third columns are the same. When we find the minors and apply them properly, we find that again our determinant is equal to 0. Therefore, a matrix with 2 identical rows or columns must be equal to 0 as well. Let us do an activity. It is time for you to try a question, students. I am confident that you have learned enough about matrices and determinants that you will be able to solve this problem without too much difficulty. Teacher, Please form the students into groups of 2. Students, please see if you can apply the principles that you have learned to find the determinant of this matrix. Please go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you selected your minors, as I think you did, your solution probably looked like this. It left you with a final equation of 162 minus 50 plus 112. You found that the determinant of this matrix is equal to 0. If you selected different elements to work with, you ended up with different minors. That is all right. What is important is that your result was correct. Good work. There are a few more principles of determinants we need to learn. Please make a note of these. Remember that any time we talk about rows, we are also talking about columns. Are you ready? The determinant of a matrix is equal to the determinant of its transpose. This means that it does not matter if you transpose a square matrix. The determinant will be the same in any case. Imagine we make a new matrix by multiplying one row or column of an old one by a scalar. If we did, the determinant would be the same as the determinant of the old one times the scalar. If we were to make a new matrix by interchanging two columns of an old one, the determinant of the new one will be the negative of the determinant of the old one. If we make a new matrix by taking an old one and adding a multiple of one row to a multiple of another, the old and new matrices will have the same determinant. Well done, students. That is a lot to take in, is it not? Once you have memorized those rules, you will know almost everything about determinants. It is time for an activity. I would like you to calculate the determinant of this matrix. After all this practice, I am sure you will do well. Please start now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. This matrix was a bit more complicated. There was a mix of real numbers and variables for elements. Let us see how you did. You see, mixing in polynomials makes the question look scarier. But you can treat the question in the same way to get an answer, even if the answer is not a nice, clean integer. By expanding the first row, we get 3 matrices. These 3 matrices then become rationalized into this equation. This step allows us to find our determinant. Here is the correct answer. I hope that everyone succeeded in finding it. If you did, very good work. You are becoming experts in finding determinants. That is all the time we have for today, students. We have learned a lot about matrices and determinants during the past few lessons. Remember that determinants are very important to helping us to deal with sets expressing linear expressions. I am confident that you will learn how to inverse the square matrix easily. Until next time, thank you, teacher. Thank you, students.